Hey folks, happy almost New Year. It's Ken again from No Brainer, and I'm back to bring you a solution to another GMAT problem solving exercise. So without further ado, let's jump right in. So the text here is a little bit small, so why don't I go ahead and read the exercise for you out loud. Pumps A, B, and C operate at their respective constant rates. Pumps A and B, operating simultaneously, can fill a certain tank in 6/5 hours. Pump A and C, operating simultaneously, can fill the tank in 3/2 hours. And pumps B and C, operating simultaneously, can fill the tank in 2 hours. How many hours does it take pumps A, B, and C, operating simultaneously, to fill the tank? There are 5 answer choices ranging from 1/3 up to 1. For those of you who've been preparing for GMAT up to now, you would recognize this right away as a typical work problem. And what are the facts here? We've got 3 things. They work at different rates. A and B can do the job in 6/5 of an hour, right? Which you would just recognize as just a little bit more than an hour. We have A and C who can do the job together in 3/2 of an hour, so a little bit slower than A and B together would do the job. And then finally you're given that BC, if working together, could do the job in the slowest time, 2 hours. Now what's also to point out at this moment is if we were really short on time and we saw what has written down here, we'd recognize, again, A and B together took 1 1/5 hours, and clearly from this information it looks like machine C or pump C is the slowest. C is contributing, but it's not going to contribute a whole lot. And if you had no time, the logical guess here would be either choices C, D, or E. Something not too much less than 1 1/5. First thing we'd want to recognize is the model. One of the models that are very typical in work problems looks like this. Now this model states that if you have machines R and S doing work, and if T represented R and S working together, then the time it takes R to do a job, the time it takes S to do a job, the time T for R and S together to do a job is represented by these 3 variables. So let's apply that formula to the situation or to the exercise we have here. We know that 1 over A being pump A, or A being the time it takes pump A to do the job, plus 1 over B equals 1 over 6/5, right? We also know that 1 over A plus 1 over C equals 1 over 3/2. And finally, we know that 1 over B plus 1 over C equals 1 over 2, right? That's this formula applied to A, B, and C, where we have times for the pair of AB, for the pair AC, and for the pair BC. Now let's never forget what it is we're actually looking to solve for. We want to know the time it takes for all 3 of these pumps to do the job together. So let me remind you that what that really means is we're looking for 1 over A plus 1 over B plus 1 over C equals 1 over some amount of time that we're looking to solve for. We'll just call that X in this case, right? Whoops, sorry, can't see that. So this is the model that we're looking to, well, the expression that we're looking to create so that we can ultimately solve for that variable X. Now, let's go back turn this back around. And let's also kind of just flip these around because we're dealing with these fractions. It'll be easier for us to look at 1 over 6/5 as simply 5/6, 1 over 3/2 as thirds, and well, 1 over 2 is fine the way it is right now. And now, this is algebraic reexpression. Remember, we're working with essentially 3 equations here, and we're looking to see if we can express A, B, and C in the form of 1 over A plus 1 over B plus 1 over C. If we can, we're going to be very close to solving this exercise. And one thing that you might recognize here is that if we take these 3 equations and add them down, and add all 3 of them together, you are going to get a model that is going to look very much similar to that 1 over A plus 1 over B plus 1 over C. Try at home adding these 3 equations down and see what you get. I'm going to do it here and come right back. Okay, so once you've added those 3 equations, look at what the result is. You have 2 times 1 over A plus 2 times 1 over B plus 2 times 1 over C equals 12 over 6. Wow, so you can quickly notice that you can factor that 2 out, and you will end up with that model we were just talking about. So let's take the 2, factor it out, and equals 12/6. And now simply divide both sides by 2, and you end up with 12 over 12, which equals 1. And ta-da! Here is your model 1 over A plus 1 over B plus 1 over C, which is what's left after we've divided both sides by 2, and it equals 1. And of course, the model is that this equals 1 over the time we're looking for, but 1 over 1 is still simply 1. So we're done. Answer choice E, 1 hour. So let's kind of just quickly review. What are some of the critical skills there necessary to solve that problem and solve it quickly? First, categorization. Know that you're dealing with a work problem. Once you understand that, you have an idea as to what tools and skills you're going to need to actually solve the problem. Second, take any word problem for that matter, and learn to boil it down to the essence and elements that you are going to need to get to the answer. And then number 3, it's helpful here to have the skills to do algebraic manipulation, because clearly in this exercise, understanding the implications of taking those 3 equations and adding them together and then re-expressing to get to that model that you needed, which was that 1 over A plus 1 over B plus 1 over C model, is in this case what gets you to the answer very quickly. And once you got that, you're good. So I hope that was helpful. I wish you a happy new year. Please, thanks everybody. Looking forward to seeing you again. Ciao.